Alright, so today we're doing disk method, but we're going to be looking at rotational solid that's not on the x or the y-axis. So we're going to find the volume of the solid of revolution formed by this region with the quadratic and these two lines. We're rotating this time around the line y equals -1. Okay? So again, the best thing to do here is to kind of sketch it. So we have a parabola that opens down. It's in its vertex form, so we know that the vertex is at 2, 3, right here. Opens down, there's no vertical stretch, so 1, 1, 2, 4, like this. So we have this here. There's our parabola. X equals 2 is this line right here, and y equals -1 is right here. Okay? So basically, we're going to rotate this area here. And we're going to revolve it around y equals -1. So this time, we're revolving it like this. Okay? Not around the x-axis, but around here. But since I'm still doing a horizontal axis of rotation, I'm still using this equation. So even though it's not around the x-axis, as long as it is a horizontal line of rotation like this, I can use this equation. Okay? Now, the next step is finding out what my radius is. So my radius at any point is going to be this distance from here to here. So I'm still using a vertical strip for the radius, which means I can still use this function on top minus function on the bottom. And the top function will always be the quadratic, so that is the -x minus 2 squared plus 3 minus the function on the bottom, which is this y equals -1. So that is my radius that I'm going to be using. Okay? Now, we can simplify this a little bit. So this would be -x minus 2 squared plus 4. Now, my area is going to start at 0 and it's going to end at 4. So we know our upper and lower limits. So now we just plug in from 0 to 4. My radius is negative, brackets here, -x minus 2 squared plus 4 squared dx. So first thing we got to do is simplify before I can take the antiderivative. Okay? So let's do some algebra. Okay, so when you FOIL the inside, you're going to get -x squared plus 4x squared dx. Then you're going to have to FOIL that out, and when you do that, you're going to get x to the 4th minus 8x cubed plus 16x dx. Now that it's in a nice neat polynomial, we take the antiderivative. So you get, there's pi times x to the 5th over 5 minus 8x cubed, to the 4th over 4 plus 16x squared over 2. No, it should be 3 over 3 because that's supposed to be squared. from 0 to 4, like that. And now it's just plugging in. Okay. Now, we have pi times 4 to the 5th over 5 minus, this will end up just being 2 times 4 to the 4th power plus 16 4 cubed over 3, and then the other side will be 0, like that. Now 4 to the 5th power, 1024 over 5 minus 4 to the 4th power, which is 256, and then times 2, 512, plus 4 to the 3rd power times 16, and don't forget that pi sitting out front. Okay, so now it's about just getting common denominators and simplifying. So you get common denominators, which your common denominator is going to be 15. So you end up getting 3072 minus 7680 plus 5120 all over 15. Since 15 is going to be your common denominator. And when you add everything, you get 512 pi over 15. And that is your volume. So again, really the hardest part about this is the algebra. Coming back up here, it looks like it's going to be really complicated, but it ends up being nice and neat. And then you just go on from there. So again, the hardest part about this is this part here. We actually have to use this. The ones that we've been doing before, it's just been minus 0, so it's just one function. But here, when we have that line moved, we're going to end up having to do something a little bit different. When we get to washers, it'll be a little bit more complicated because there's going to be a function underneath there. So there will actually be a function minus a function. But we'll do that next week.